Hello, ma'am. Good evening.
Yeah, good afternoon. Hi,
Yeah,
Princey. How are you?
yeah, I'm good, ma'am. How are you?
I'm also fine. Shall I start my expert?
Yes, ma'am. Ravi, sir, are you there, sir? Hello. Ravi, sir. Ma'am, give me 1 minute, ma'am.
No problem, Princey.
Ravi, sir, are you there? Sir, yes, sir.
Okay, so I'll share my screen. Okay, my screen is visible. Okay, so we'll start or we'll wait for 5-10 minutes because the previous session just finished 2 or 3 minutes before. Participants, or we'll wait for 5 to 10 minutes.
Hello, sir. I think we'll wait for just for 5 minutes. That is enough, sir.
Okay, ma'am, you can unmute from your side for the time being, so that anyone if want to, let's say, ask anything in between, because I don't have control to do that.
No problem, Dr. Ravi. I'm already unmuted and my camera is also on.
Okay. Sambhu
We are
sir, can you
waiting
unmute?
for 5 more minutes. We are waiting
Yeah,
for
5
another 5
minutes.
more
Maybe we
minutes.
can start at 3:50. Is okay?
3:50.
Yes.
Okay.
5
No,
0.
sir. I think we'll start by 3:45, sir. That will.
3:45. Okay.
Yeah, because we have to end this last session by 5:30, sir. So we'll start at 3:45.
And you please, Princey ma'am, you please remove the control for participants to mute and unmute, so that if anything is there in between, participant
Sir,
can ask.
actually, then we have to make all the participant as a presenter. So that
No,
is
no,
the.
no. Okay. Sambhu sir, are you there?
Yes, sir, that is done, sir. That is done. That is already done, sir. All
No, no.
previous.
You go to your and then you make control to the student. Oh, sorry, participants for mute unmute.
I shall give the permission to all.
Yes, yes.
So then that same problem as in the first session would happen.
No problem. I will take care. Don't worry. Yes, no?
Done, sir.
Okay, fine. Thank you. Okay, so participants, you can unmute if you want to say anything. So we are going to start in 2-3 minutes. Am I audible to you? Anyone, please tell me.
You're
Yes, sir,
audible.
you're audible.
You're audible.
Okay.
You're audible.
Thank you.
देखो तीन ऑप्शन दिए मैंने। अभी कैमरा का जिसका प्रॉब्लम हो रहा है ना, मुझे लग रहा है 3 तरह के ऑप्शंस अवेलेबल हैं।
Sir, I think we can start, Ravi sir.
Okay.
Ma'am, ready? Nonita ma'am, if you're ready, we will start the session.
Nonita ma'am, are you there, please?
Yes, sir, I'm here only.
Yeah, you can switch on your camera, please.
Okay, sir. How many participants are you expecting, sir?
Please repeat again.
How many participants are you expecting? I
Right.
guess quite a decent number of students have already joined.
Yes. So right now 78 participants are there, and
Okay.
all are faculty members, and few persons are from industries, right?
Okay.
So this is FDP program sponsored by AICTE, and
Okay.
AICTE suggested that faculty from AICTE sponsored or AICTE affiliated institute can take the benefit of this particular.
All right. So I guess I should start now.
Yes, I will introduce first, and then, so good afternoon to all participants and to the speaker, and thank you to this one. And Dr. So first I will introduce speaker. Dr. Nonita Sharma is working as Associate Professor, NIT Jalandhar. She received BTech degree in Computer Science Engineering in 2002, MTech in Computer Science Engineering in 2004, and PhD in Wireless Sensor Network from NIT Jalandhar in 2017. She has more than 10 years of teaching experience. Her major area of interest includes data mining, bioinformatics, time series forecasting, and wireless sensor networks. She has published several papers, international, national journals and conferences and book chapters. She received Best Paper Award for her research paper in Midterm Symposium organized by CSIR Chandigarh. She has authored a book titled XG Boost. XG means extreme gradient, the boosting for mining applications. Yes. So now over to Dr. Nonita Sharma. So now you may continue. So session is in your hand now.
Okay.
You are welcome. Thank you.
Thank you so much, Dr. Ravi, and a very warm welcome to all the participants who are attending these courses, FDP. I'm pretty sure that you will be learning a lot from these sessions. I've been told that the last session has just ended, I guess, 10 minutes back. So you all must be a little tired. So you needed a break. So I'll try to make my session as interesting as possible so that all of you should be awake after 2 hours. So as let me share my content first. All right. Can somebody tell me that are my PPTs visible?
Yes, ma'am.
Okay. That's it.
Yes.
So we'll be, thank you so much. So we'll be talking about time series forecasting for financial applications. So the agenda which I'll be covering is, initially I'll be giving you a complete basic knowledge of time series forecasting. And then I'll be talking about financial applications. We'll be taking a project related to Sensex, BSE Sensex data, and how do we actually forecast stock markets. So at the end, I'm going to give you a little hands-on on stock market prediction. So talking about the presentation, we'll be discussing the basics of time series forecasting, why this time series decomposition is required, and what do we actually understand by stationarity of the data. And then we'll be talking of ACF and PACF plots, and then the various models that we employ for time series forecasting. And as I've told you, I'll be taking a little hands-on for a pilot project, that is stock market forecasting, and then I'll be introducing ensemble modeling a little bit. And then the various result evaluation metrics which we employ to actually check the results. So if we talk about time series data is that kind of a data which will be collected on a consistent time interval. So the main difference between data and a time series data would be that there will always be a time element associated with the data when we are talking of a time series data. So if there is no time element associated with the data, then that data can never be classified as time series data. And that time, it could be any scale. It could be hourly, it could be in minute wise also, and it could be decade wise also. But it has to be collected at consistent time intervals. So because of this time element, what we say is that this time series is different. This forecasting and prediction is different from other regression problems or other problems in which we have just numerical data. Why? Because in this case, what we are saying is that the current value might be dependent on the previous data points. So if I give you one example, which is in front of you, there are two examples, example data. The first one represents the loan prediction example of regression. Now, suppose if we have got the data which actually contains the loan applications of various applicants, then we can definitely say that, okay, this application might not at all be related to the previous application, because these things depend upon a lot of things like income per month, loan type, loan amount, what was the status and everything. So one loan the applicant will never be related to the previous loan applicant. So these kind of problems actually fall under the category of regression problem. But when we are saying that, okay, I'm going to approximate the amount of COVID cases in the next month, or I'm going to approximate the amount of carbon dioxide for air quality indexing, or I'm going to, for example, say forecast of rainfall forecast. You know? So definitely these values are dependent on the previous values. So when you are employing these kind of data, then that data is called time series data. Formally, if we define it as, it is a time series is a collection of data points that is collected at constant time interval. Now, this constant word is very important. So if your data is not constant, then in case of data pre-processing, you have to actually make your time series constant. Otherwise, you cannot be, you will not be able to classify that data as time series also. So I've just told you that, okay, we have got two important points. One, if the data has got date or time element attached to it, and secondly, it has to be constant. Means if you're collecting the data daily, then it has to be daily only, right? You cannot miss 2 days, 3 days, 4 days in between and then start collecting daily and then you're missing a few days. No. And I have already told you that why it is different from regression. Time series, it is time dependent, and also it can show you properties like trends. We can say that, okay, the data is showing increasing trend, decreasing trend. There might be certain kind of seasonality involved in the data. So these are the few features of time series which actually makes it different from the regression problem. So that is why we are saying that regression tools and techniques are not available in case of time series data. So mostly our financial data is a time series data in which we are actually collecting the financial data at regular intervals of time. So whenever the prediction of financial data involves, we are always employing these time series models and techniques. So this time series have got numerous applications in sales forecasting, stock market prediction, weather forecasting. So time series, it can be classified into two major categories. One is your discrete time series, in which what we are doing is we are collecting the data at a particular discrete set. For example, if I'm saying that, okay, I'll be collecting the data at this point, at this point, at this point, that is going to be the discrete time series. Continuous time series is when the observations are made continuously over some time interval. For example, a sensor data is being collected continuously for 1 year or 2 years, and then again we are analyzing that data. So when you're saying that, okay, I'll be collecting the data only at 9 a.m. in the morning every day, so that kind of a time series would be classified as discrete time series. So if we talk about the component of time series, these are very important. So actually these components make it different from your regular data. The first one is trend. Trend you can see entirely from the graph. For example, if your data is showing certain kind of linear or non-linear component, which is either decreasing or increasing, then that will be called trend. For example, in this graph which is given to you, the yellow line that represents the trend of the data. It is actually showing the increasing trend. Then is the seasonality. So any kind of pattern which is repeated over the seasons. For example, the best example could be the sales of air conditioners. Normally, the sales of air conditioners are high during the winters, during the summer seasons, and during the winter season, it actually touches the trough. So peak जो है that you get during the summer seasons, or otherwise it is at the down during the winter season. So seasonality, the thing which is shown with this thing, that is called seasonality. And then is a cyclic behavior. If a particular behavior or a particular pattern is repeated regularly, then that will be called the cyclic behavior. For example, if the data is showing increasing and decreasing trend and that is repeated after few intervals, then that is called cyclic. So the main component of time series are trend, season, and cyclic behavior. And the last one, which is very important, that is called random or noise. Irregular component in your time series, that will be classified as random or noise component. So in a way, there are four components of time series: trend, seasonality, cyclic behavior, and the random component. Now, this particular concept is very, very important. This is called stationarity of time series. Now, the stationarity, what do we understand by stationarity of a time series? If my data or if my time series is showing certain kind of stationarity in the behavior, only then I'll be able to predict or forecast future values. Now, what is the stationarity? Stationarity is defined with the help of three important statistical measures, that is mean, variance, and covariance. You have to understand that the mean of the time series, it should not be function of time. What I'm trying to say is that with time, the value of mean should not increase or should not decrease. It should not be dependent upon time. It should remain constant over time. For example, the green graph, the first graph, the green, it shows that the mean of the series is constant, whereas in the red, it is showing an increasing line. The second thing that we always classify in order to find, that is variance, the variance of the data. The variance of the time series, it should not be function of time. It should not vary. It should not be like this, that okay, sometimes it is very low, sometimes it is very high. It should be a function. It should be constant with respect to various values. And third thing is covariance. When I'm saying variance, variance is of the entire data and covariance is of this term with the next term. Okay? When we are talking of two terms, so the covariance of ith and I plus mth term, it should also not be the function of time. It should not vary with respect to time. 1 second, give me 1 second. Hello. Hanji. Okay, I'm sorry about this interruption. So if your time series is non-stationarity, that means your mean is varying or your variance is varying or there is no relation between this term and the previous term, then we cannot apply these models. So the best way is either your time series should be stationary or if you have to convert your non-stationary series into a stationary series. Okay. So, what are the various ways? For example, the graph which is given to us, it shows that there is an increasing trend and there are also certain kind of seasonal variations. So, by looking at this time series, you will not be able to tell that whether your series is stationary or not. So, there are few statistical tests which we can do, which can actually tell us that whether the series was stationary or not. The first one is plotting rolling statistics. In that case, what we can do is we can actually plot the moving average and see whether it varies with time or not. Right. So what we are doing is that we are taking the average of the some interval, for example, 1 year, 2 year or something like that. And then we see that whether the average is moving or it is remaining constant. So if it is remaining constant, then we can say that, okay, my series is stationary. If it is moving, sometimes increasing, sometimes decreasing, then we can definitely say that, okay, it is not stationary. But looking or visualization technique alone is not going to give you the correct result. So another statistical tool that we normally employ in case of time series forecasting is Decay Fuller test. So this is the statistical test that we employed for checking the stationarity. Here we are assuming that the null hypothesis is that time series is non-stationary. And then we try to find out the value of this P constant in this case. If the value is lesser than the critical threshold, that is taken as 0.05, then we reject the null hypothesis and says that series is stationary. Okay. So next, very important component that is called autocorrelation. Okay, so the random component, the last component that we said was that was the residual or the error. Okay, so when we're talking about autocorrelation, then what we are trying to say is that whether the residuals, they are correlated with each other or not. So what do I mean by error? For example, I have forecasted the data. Now I'm plotting the data. Okay, I have forecasted the data for 1 week. For the first day, what was the error? Suppose the error was of 5 unit. Okay, the actual value was 20 and I predicted 25. The second day, the error was of 10 unit. Third day, the error was of 15 unit. Fourth day, the error was of 20 unit. So what we are actually trying to see is that the error which my model is predicting, whether there is certain correlation in those values or not. right? So here comes the concept of ACF and PACF plots, right? So when we are plotting, when we are actually trying to forecast the data, there are two things that we are going to consider. The first one is whether the values are related to the previous values or not. Okay, for example, if I'm saying that, okay, today's temperature here is 30 degree. Tomorrow's temperature was also 30 degree. The next day temperature was also 30 degree. The next day temperature was 31. So what we can see that today's temperature was dependent upon the previous values. Okay, so the one thing that we are going to consider is the actual values of the data, right? And the second thing that we are going to consider is the error term. Error term is that what I'm predicting and what actual value was. So whether the errors they are also correlated or not, whether the values they are also correlated or not. So the common statistical test that we employ for autocorrelation is Durbin-Watson test. Again, this is a statistical test and its value ranges from 0 to 4. If the value is close to 2, then that shows there is no correlation between the error terms. But if the value is closer to 0 or to 4, then it shows the positive or negative correlation between the error values. All right. So basically moving to modeling time series or understanding the various time series model, I'm just going to summarize the first concept that we have covered. First thing is what is time series, how it is different from regression data, how is different from the data in which we employ our regression models. Second thing is that, okay, how many components are there in a time series. Third thing is that what do we understand by stationarity of data and why this stationarity is not required? Because if there will be, the data is non-stationary, then we will not be able to predict or forecast. And the fourth thing is autocorrelation, or what we are trying to say over this is at the conclusion of this first topic that we have done is that while forecasting, we'll be considering two things. One, the values which we are actually going to predict, whether those values at different time intervals are related to each other or not. And second thing, whether the error terms, residual error terms, whether they are related to each other or not. So modeling time series, there are so many models to predict time series data, and few of them actually give very, very good results. So I am just talking from the basics so that we could get a complete understanding that how this particular field evolved. The first one was naive approach. So in this forecasting technique, what was there is that the value of new data point is just predicted to be equal to the previous data point. That's it. And normally this approach is used by managers, decision makers, and everyone where we are not actually using any statistical tools. So my percentage, suppose in this semester, is 80%. And if I ask you that, okay, what are you expecting that how much I'm going to get in the next semester? You definitely are going to say that you will be getting 80, around 80. Right? So we can say that, okay, the placement of our college this time is 90%. So what will be the next time? It will be almost 90%. So normally the tendency of human is to predict whatever is the current value, that is going to be the future value. So that is simple. So this is the naive approach, that the value of the new data point is going to be the same as your previous data point. But in this case, the forecasting, if you see the orange line, it will be the parallel to the axis, because initially the value was same as the previous point, and next all the values were the same. We are not actually considering the trend and trend of the data which was given to us. So this is not used at all nowadays. Now the second thing is simple average. Simple average is that, okay, I'm going to take the average of all the previous values. Right. So in this case, the predictions are obviously better than the naive approach because it is not going to result in a flat line, but all the past values are taken into consideration. Now, what is the problem with this is I have to predict, suppose stock market index only. I have to predict that, okay, what is going to be the value of BSE Sensex tomorrow? And I have the data from 1990s and I'm taking the average of all the data. So how it is going to impact my decision on the next data? The latest values have got more influence. What influence of 1990s data would be on 2021? Very less, very minimal. So the point of averaging all the values, that is actually going to make your prediction accuracy poor. It is not going to make the decision more accurate, right? So again, simple average is not very highly used. Now, the next thing is your moving average. Again, moving average is also the kind of naive only. In this, what we are doing is this. For example, I have told you that, okay, we are not going to consider the average of all the previous values, but when I see that, okay, I am going to take the average of last 1 month, or I am going to take the average of last 2 months, because these 2 months data actually impact my stock market. So I'm going to take the data of that only window. So moving average is that, okay, instead of taking all the past observations, I'm going to take a window that, okay, up till this point, I'm going to take the average of previous values, and that is going to be my forecast. Now, again, this particular approach has a problem, because what we feel is that latest values have got more impact on the prediction rather than the previous values, right? So what the value of BSE Sensex is today, that is going to have the major impact on what its value will be tomorrow, rather than the value which was there on the before 2 months, right? So here comes the concept of weighting moving average. So what it does is that it gives weight to the values. More weightage is given to the recent values and lesser weightage is given to the past values, right? So weighted moving average, it is the moving average where the past n values, they are given different weights, and the recent observations, they are given more weightage than those observations which were past values, which were past, recent. So, okay, and this is called exponential smoothing also. This particular thing, this is called exponential smoothing. And here what we use is, we use the alpha as the smoothing factor. Next what we are going to consider is Halt winter method. First, we are going to consider linear trend, and then we are going to consider seasonality as well. Now, what we are saying for the past 4 model is that, okay, this value is dependent upon the previous value, previous single value, or previous average of all values, or previous average of n values, or weighted average of previous n values, right? But what we are doing is, we are not considering the trend also. Okay? So we have to consider the trend also, that whether my series has got the increasing nature or decreasing nature. Okay, so if a model consider trend as the part of forecasting function, then that model is your Halt's linear trend model. In this, the value will be the average of the previous, weighted average of the previous values, as well as what we are considering is a function of trend also. Right, and the second model is, which is going to consider trend as well as seasonality also. Okay, whether my time series is showing increasing trend or decreasing trend, and whether there is certain kind of seasonality involved. For example, the number of bookings in a hotel that is high on weekends and low on weekdays, right? And it may be increasing every year. You know? So that means there exists a weekly seasonality, that every weekend it is showing an increasing trend, and on weekdays it is showing a decreasing trend. So it is kind of a weekly seasonality and an increasing trend overall. Right. So in this, what we are going to consider, we are going to consider 2 equations, one for the trend and second for the seasonality. Now, these were the models on which our latest models are actually based upon. So the first model, which is very, very widely used, that is called Arima model. So Arima model is based upon 2 important concepts. The first one is auto-regression and second one is moving average. Enough. When I concluded the first section, that is, while considering time series, we are going to consider 2 things. One was the values and second was the error terms. So this Arima model, this is based upon these 2 important topics. The first one is auto-regression. So when I'm saying auto-regression, what I'm trying to say is whether my value is dependent upon the previous value or not. right? So when you're just considering the values, for example, today's temperature would be dependent upon the yesterday's temperature, or today's stock market value is dependent upon the previous stock market value, right? So that thing is represented using AR term. It represent auto regressive. Now the equation which is given over here is the equation which is given over here is xt is equal to alpha xt minus 1. So what it represent? It represent that the current term is dependent only on the previous term. So if it is dependent upon other terms also, then the equation would be alpha 1 into xt minus 1 plus alpha 2 into xt minus 2 up to alpha xt minus n. Right, whatever the previous values that you have found out that, okay, how much values it is dependent upon, and W is called the white noise term. So obviously every time when you are predicting or when you are forecasting or you're saying that this value is dependent upon the previous value, there might be certain error or noise involved. Okay, now the second one is your this one term AR1. When I'm writing AR1, that means the value is dependent only on a single term. Okay. Next is MAQ. MAQ is what this moving average represent? It represents the past error terms. Rather than AR represent the past observation value, MA moving average, it represents the combination of error terms. So if I'm saying that the error is dependent only on the previous error, right? So what do I mean to say is that, okay, day before the data was 200 and my model predicted as 220. And the next day also the data was 210 and my model predicted 230. So there is a certain kind of correlation between these error terms. Initially also 200 and I predicted 220. So 20 was the error terms. Next day also 210 and 230, the error term was 20. So whatever my model will predict, I'm going to add 20 in that, right? So this thing represents your moving average. Okay. So again, this MA1, this has represented that, okay, the error term of this particular term, current term is dependent only on the previous term. If it is dependent upon n terms, then the equation would change to B into ET minus 1 plus B into ET minus 2 up to B into ET minus n. Okay. So Arima model, which I have just covered, this is AR, it represents to the past values, and MA, it represents the forecast errors. Okay, so if you have to represent the equation, it will be represented like this, that the current value is dependent upon a particular fraction of the previous value as well as the error terms, and this is the overall noise term. So this is 1 and 1. That is only on the previous 1 value and only on the previous error of 1 value. Now, I have talked about the stationarity and non-stationarity of data. So if your data is non-stationary, that the mean is not constant over time, the mean is varying. Either it is increasing or it is decreasing, the mean of the data is varying, then in that case, what you have to do is you have to subtract those values which are actually making your data non-stationary. You have to make your data stationary by using differencing. Right? So you are going to make the differencing, you are going to use logarithmic or you're going to perform this differencing so that your data becomes stationary. So how many times you actually have to subtract those values, that is called differencing here. Okay? So Arima is the model which is actually applied on non-stationary data. Arima was the model which was applied on only on the stationary data. Okay, so Arima model, there were two variables, that is P and Q. P was representing AR, Q was representing MA. Now in this case, Arima. In Arima, there is another variable which will be D. D will actually represent differencing. That, okay, how many times you have to perform the differencing in order to make your non-stationary data a stationary one. Okay, so that is the importance of Arima model. So Arima model, it can be applied to non-stationary data, but the model will not give you the result on non-stationary data. What it is going to do is, it is actually going to convert your non-stationary data into stationary data, and then it is going to give you the forecast values. So Arima essentially performs the same function, but it does so repeatedly D times in order to reduce a non-stationary series to a stationary one. So Arima model, it has got three components, very important: autoregressive term, I, that stands for differencing term, moving average. AR terms, it refers to the past values. MA terms, it refers to the past forecast errors, and order of differencing actually represent that, okay, how many times you have to difference in order to make your data stationary. Now, when we're talking of accuracy or prediction, definitely there are few performance metrics there which we use to actually check what are the results or whether our model is performing accurately or not. So what is an error? Error is actually the difference between the actual value and its forecast value. Right. So this is how we measure the error. Whatever is the actual value of the data and whatever is the forecast value, the difference is going to be the error. The metrics are, the first metric that we use is the mean error. Okay, suppose you have predicted 10 values. So what was the error in each term, and then taking the mean of those 10 values, that is going to be the mean error. Definitely this particular error metric has a major flaw, that if out of those 10 values, 5 were on the positive side and 5 were on the negative side, they are going to cancel each other and you will not be able to get the correct mean. So that is why the next model that was there, that we said that, okay, we are going to use the square term. The only reason of using square was not the mean thing. You can have used mod also. The square term was used by, because when we are trying to give more emphasis on larger values. So when we are comparing 2, if I've got the error of 2, if I've got the error of 3, if I've got the error of 4, when we are actually squaring these values, 2 becomes 4, 3 becomes 9, 4 becomes 16. And as we go, this square value actually becomes larger and larger. Okay, so when you're actually going to put more emphasis on larger value, what you're doing is we're actually squaring that error. Okay, so that the people can focus on, okay, these are the more errors in the system. So if somebody asks you that where we use MSE and where we use mean average error is used when there is a uniform distribution of error. We are not, each error term is given equal weightage. In that case, what we are going to use is we are going to use mean absolute error. In some cases, when we are actually trying to put more emphasis on larger values, then we are using MSE. But the major flaw in case of MSE is mean square error is the unit of the error metric that becomes different. For example, if my data is of length, the unit would be centimeter, but the MSE, it is going to give you the error matrix in centimeter square, which is not correct, obviously, right? So in that case, what we use is we use RMSE. We actually take the square root of this thing. And the last one I've already told you, mean absolute error. We will not be using mean error because mean error cancel out each other. Absolute is we are taking the modulus of these two errors. Okay, now before going for ensemble modeling, let us see that what exactly we have to do in case of financial data. Okay, suppose I have to download this data, BSc Sensex data or any stock market data or any indices data, right? The data is available online. You can download it from any official website. For example, Bombay Stock Exchange, I'm using BSc India, or Yahoo Finance is there. You can use that also. NSE, that you can use also. If we talk about the indices, these are the various indices that are there. So whatever the prediction data, I hope my screen is visible, right?
Yes, yes, ma'am.
Okay, fine. Suppose I take this data and I can have the data is daily, as monthly or yearly. It all depends upon that what exactly are you trying to predict. And suppose I take the data from 1st January to 1st September. I have downloaded the data. I would like to ask you only that what do you think?
Yeah, dear participants, you can unmute and reply. You have control of your mic in your hand. Or I will ask one by one. I think that is not good, right? So you please voluntarily you reply to the question what is asked.
Ravi said that is not a problem. If they
Yeah, you may name the person and then you can ask. Or if he
no,
is not replying, then
that
you
would
can
be
ask.
okay for me. So when we are talking of Sensex data, what we have collected is the data which I have downloaded just in front of you. The date is there, open, high, and low and
Yeah,
close. So,
Rajnish Kumar, you want to say something?
so
No, sir.
Kumar. Yeah,
Actually, I
please.
want to give the answer. Meanwhile, the problem
Yeah,
is
yeah,
solved. No?
please continue.
okay.
Rajnish Kumar,
So
please.
I have not asked any question, Ravi sir, yet.
Okay, fine.
Okay, so I have got 4 values. That is the opening value of this opening value on this particular date, the high value, and the low value, and close value. So you can predict on any of these values. Huh? You can, for example, I have to predict for tomorrow. I can predict on opening that at what value it will open, or what is going to be the high value tomorrow, what is going to be the lowest possible value tomorrow, and what at what the markets are going to be closed. Okay, so we can predict on any of these values. So you can predict any of these. If I take close. Now, if somebody, Rajneesh, I would like you to answer only. If you look at the data, it is on a daily basis. Huh? 1st, 4th June, 5th June, 6th June, 7th June, 8th June, and 11th June. So, can Rajneesh, we classify this data as a time series data, or do you see any problem in this? I just told you whether this data, if you look at the dates, 1st January, 4th January, whether you see that, okay, is it okay or there is a problem? We need to pre-process it to make it time series. Or do you think that this is time series because there is a time element attached to it?
We need to process it, madam. No?
Can you say it again? I couldn't hear you. I'm sorry.
Need to process it in time series.
Correct. Correct. We need to pre-process it. Why do you think that we need to pre-process it? What do you think is the problem here?
Because the sequence.
Correct. There are few values which are missing, right, Rajneesh? You can see that 1st January and then 2nd and 3rd, those 2 values are missing, right? So why they are missing? Because the markets are closed on Saturday and Sunday. Right. So 2nd and 3rd must be Saturday and Sunday. Similarly, after 8th, 9th and 10th would be Saturday and Sunday. So we need to pre-process the data. Either we can do the pre-processing in your programming language, Python or R, or we can pre-process the data on the Excel also, right? I would like to show you the pre-processing here itself because it's a good thing and you will be learning this. You will first of all, what we have to do is we have to see that whether this column is represented in terms of date or not. Because this element has to be in date only or time only then this will be classified as time series. But if you look, this is in the general format. So we are going to convert it in date format. Okay, now what I have to do is I have to fill these values which are missing, that is 2 and 3. I will not be able to do it like this because it's a huge data. I have taken only from 1st January. The data that you consider might be for past 2-3 years when you are actually doing the project or you are actually doing this. So what I'm going to do is I'm just going to show you that, okay, what are the basic steps? This is very easy. Suppose I have written this is also date. I have checked it. This is date. You can take any format from number format and I am going to keep this जहां तक हमारी dates है. हमारी date जो है, last date जो है, that is 1st September. So I am going to take it up to 1st September. Because I want continuous value. That is my problem, है ना? My time series will be this. Because इसमें कोई value missing नहीं है. Are you getting what I'm trying to do? Right? So now what is there is, we want to fill those values which are there empty, है ना? जो वहां पे यहाँ पे 2, 3 आ जाए, यहाँ पे 10 और 9 आ जाए, तो what I'm going to do over here is I'm going to use a function called match. ठीक है, मैच हम कहते हैं कि हो जाए उसकी वैल्यू आप डाल दीजिए. किससे मैच करना है? इससे कॉमा इनसे. जहां जहां पे मैच है वहां वहां पे आप वैल्यू डाल दो. जहां जहां पे मैच नहीं है वहां पे आप कुछ भी खाली वैल्यू रख दो. ठीक है, बिकॉज हमें क्या करना है, हमें इस डेटा को एक्चुअली प्री प्रोसेस करना है. ठीक है, जब हम इसको अरे फॉर्मेट में करते हैं देन वी पुट डॉलर ओवर हियर. ठीक है, इन केस ऑफ मैच फंक्शन. So this is 0. There they have written if we want to match lesser than that particular value or exact match or greater than. We want exact match. जो dates है वो तो उसका तो आप number दे दो, जो dates नहीं है उसको आप not applicable कर दो. Right? So you can write these steps also because maybe आपको बाद में ये भूल जाएं, but this is very important thing. So what is there you can easily see. We can see that, okay, this particular data is lying at number 1. This particular data is lying at number 2. These two data is not found in this particular series. ये दोनों डेटा जो है ये यहाँ पे अवेलेबल नहीं है. ये मैच आपको क्या देता है? मैच आपको देता है कि एक पर्टिकुलर डेटा जो है वो कौन से नंबर पे वहां पे लाई करता है. Correct? Now what we want is we want to fill these 2, 3, the data which was not there, we want to fill those values, right? So what I'm going to do is I am going to actually sort it. I'm going to custom sort on the basis of E value, है ना? All right. So all not existing values, they are there. Okay. So what I'm going to do over here is I am going to first step मैं क्या कर रही हूँ, मैं वो सारी dates लिख रही हूँ जो कि missing थी. Right, that is my purpose. First purpose मेरा ये, और मैं खुद से नहीं लिखना चाहती हूँ because that is going to take me a lot of time. So what I'm going to do over here is I am just going to create those values which were not there. Correct? So I am going to copy those values which are not there, which were given using NA. Okay, I have taken from there. Correct? So these values are now, if I sort it, you'll be able to see. So my first purpose is solved. Am I clear? What I have done is I have created those dates which were missing, right? 2, 3, oh, so I'm sorry about this. 2, 3 was missing. This date is there now. I do not have to write it manually, obviously, right? 9 and 10 was missing. It is there. Till 9th September, till 1st September, all the empty spaces are there now. Now, what these values should be filled with? Obviously, if the market is closed at this point on Friday, on Monday also, this value will be there. It is going to be the same value. Why? Because the markets were not open, so this value will not be changed, correct? So what we are going to do over here is, we are going to make this value equal to the previous one. Am I correct? What I'm saying, are you able to understand?
Yes. Yes, ma'am.
Right? Correct? Now the second thing what we have to do over here is, we have to put the values as the previous values, right? So on Saturday, the value will be same as the Friday, as well as on Sunday also the value will be same as Friday. Again, I'm not going to do it manually. Just give me 1 second. I have to move to some other place because there was a certain electricity issue over there. Yeah. Can you hear me? Am I audible?
Yes, ma'am.
Okay, fine. All right. So the next thing that we do is, we have to find out blank spaces. Hai na? So how do we find? We press Control G. In this special, we are going to select the blanks. Okay, so these are also considered as blanks because इसमें हमारी पहले से value पड़ी हुई थी open वाली और close वाली, high और low वाली. ठीक है, तो इसको भी वो select कर रहे हैं. हम नहीं चाहते कि इसको select करें. Normally अगर हम इसको clear content and delete कर देते हैं, then it works. ठीक है, but even if it does not work, that should not be a problem. You just copy and paste it over here. Right? Now you find out the blank values. You go to Control G, Special and Blanks. Now the value which are blanks, they are highlighted. Correct? What do we want is equal to the sign. The value should be previous one. And then instead of pressing enter, what you need to do is you have to press Control Enter. Okay. Now what is there? All the values which were blank, okay, they were filled with the previous value. For example, this was filled with the previous value. This was also filled with the previous value. This on the 9th, it was filled with the previous value. So this is one way of pre-processing. Or what you can do is, instead of the previous value, you could have entered the average value also. Or you could have entered the highest value also, mode also, median, sorry. Or you could have done the most occurring value, that is mode also, right? So this is how we actually do the pre-processing of financial data. Okay, why I've taken this example is because you should know that, okay, this was the main problem. Otherwise, in financial data, the data is very, very good, clean data. Instead of only this is the problem. Normally, there are no missing values or there are no null values because the market is always open and you will always get the values. So this is the main problem that occurs in financial data. So you have to pre-process it like this. Now, if you look, I hope this pre-processing is clear to all of you. If you want, I can repeat these steps also. Is it okay? Is it clear?
Please repeat the pre-processing in XLS.
Yeah, sure. I'll be repeating those steps, but it is my humble request, because all of you are my colleague only. You just write down these steps, because sometimes what happens is when I am doing, you will feel that, okay, these are very easy, but later on, maybe in a day or two, you might forget one of the steps. So I'm going to repeat it and I'm going to do it again slowly also, because there was disturbance also. I could understand this thing. Suppose I have taken the data from any date you can take, right? From January to September, right? Submit. I have downloaded the data. This is the data that I got, right? You can do the prediction on any of these indices. Every index is going to give you these values. These are not indices, I'm sorry. These are the various values of your index. Opening index value, the highest index value in that day, the lowest index value in that day, and the closing index value. You can work on Arima model. It works on univariate data. Univariate means only on a single variable. So it will be able to predict only a single variable at a time, right? So we have to delete all other values. Suppose I have deleted all these 4 values. I don't need this. Okay, I am doing the prediction on opening values. So we can easily see that this data is a time series data. There is a time element. When I say time, so time means date and time both, right? So there is a time element available, but if you look, it is not at the constant interval. 4 and 5 are missing. Similarly, 11 and 12 are missing, right? So we have to make this data clean data. So what I do is here, and you have to see also whether this data is in date format or not, है ना? तो date format में नहीं है, तो you have to make it a date format. It's in the date format. Now if I see new, इसमें ये जो values missing है, ठीक है, जैसे 4 और 5 मिसिंग है, तो या तो मैं यहाँ से खुद लिखूं 4 और 5, विच इज नॉट पॉसिबल, ऑब्वियसली इट इज नॉट पॉसिबल, या फिर मैं कुछ ऐसा करूं कि ये वैल्यूज जो है ये अपने आप से आ जाए, ठीक है. सो व्हाट आई एम राइट नाउ आई एम डूइंग इज मैं पूरी की पूरी वैल्यूज ले लेती हूँ, ठीक है. देखिए यहाँ से ऑलरेडी डेट फॉर्मेट में ही है, तो मैं पूरी की पूरी वैल्यूज, देखिए कहाँ तक, जहां तक ये वैल्यू खत्म हो रही है, देखिए आप, तो ये वैल्यू 9 सितंबर पे, सॉरी 1 सितंबर पे खत्म हो रही है. फर्स्ट जो कॉलम है 1 सितंबर तक, ठीक है. लेकिन हमारा जो 1 सितंबर तक हम नहीं पहुंचे हैं अभी, हम सिर्फ 20 फेब तक पहुंचे हैं. क्यों? क्योंकि हमारे वाली डेटा में सैटरडे एंड संडे भी आ रहा है, तो हमें जाना है 1 सितंबर तक. Right? So it contains all the date values from starting date to ending date. There is no missing values in this data, right? So I have to put the missing values in the previous values. So in that case, what I'm going to use is I'm going to use a match function. Match says कि जहां पे match हो रही है value, उसको रख लो. Match किसके साथ? इसके साथ, इस कॉलम की इसके साथ, कहां तक? स्टार्टिंग से लेके एंड तक, ठीक है. सो मैच में आपके पास 3 ऑप्शन है, लेस देन, एग्जैक्ट मैच या फिर ग्रेटर देन मैच. मैच आपको उस पर्टिकुलर वैल्यू की लोकेशन बताती है. इट सिंपली टेल्स यू दैट ओके व्हाट इज द लोकेशन. जब आपने पूरे, आई एम सॉरी अबाउट दिस, पूरे अरे के साथ आपने कंपेयर करना होता है, तब हम इसके साथ डॉलर साइन लगा देते हैं. सिंगल वैल्यू जब आपने कंपेयर करनी होती है, तब हम डॉलर साइन नहीं लगाते हैं. मैच का क्या पर्पस है? सिंपली वो ढूंढता है कि ये वैल्यू यहाँ पे कौन सी लोकेशन पे एग्जिस्ट करती है, ठीक है. जैसे उसने हमें बताया कि ये वैल्यू जो है ये फर्स्ट लोकेशन पे एग्जिस्ट करती है, तो हमने कहा कि ठीक है, सारी वैल्यूज हमें बता दो. ऑल राइट, ठीक है. तो इसमें सॉरी, आई एम वेरी सॉरी, इसमें जो वैल्यूज एग्जिस्ट करती हैं, दिस एग्जिस्ट एट नंबर 2, दिस एग्जिस्ट एट नंबर 3, एंड दिस वैल्यू डज नॉट एग्जिस्ट. सो वी आर मोर इंटरेस्टेड इन दीज वैल्यूज सो दैट वी कैन पुट दीज वैल्यूज in our date column. So what we are going to do is we are going to do the sorting. All right. So these values, these all are not available values. So I am just going to copy it and paste it in the first column so that these values become part of my original data. This is there. I have copied the data. I am just pasting it over here. All right. So these values should be at their own places. So I'm just going to sort the data. That is not a problem with us. We are going to sort it on the basis of date, newest, ओल्डेस्ट टू न्यूएस्ट है ना. पहले हमारे पास अभी भी पुराना ही डेटा सबसे पहले, तो ओल्डेस्ट टू न्यूएस्ट कर लिया. चलो, न्यूएस्ट टू ओल्डेस्ट. दिस इज सितंबर से अगर आपने डेटा लेना है तो न्यूएस्ट टू ओल्डेस्ट, अदरवाइज आप ओल्डेस्ट टू न्यूएस्ट ले लीजिए. ठीक है. सो हमारा फर्स्ट पर्पस जो है वो सॉल्व हो गया. So now the second purpose is that we want to fill those values with the previous values, right? So we have to select all the blank spaces. So the only thing that we do over here is press Ctrl G. Matlab, if you have laptop also, you can do it along with me also. Special, select the blank spaces. So all the blank spaces will be selected. So अगर मैं यहाँ पे ये कर देती हूँ equal to previous value, suppose, and then I press Ctrl G. So what is going to be the problem here? These values will be there, है ना. जो last value वो उसी को ही लेता जाएगा, लेकिन हमें ये खाली वाले columns को नहीं रखना था, तो हम इसको clear content करके एक बार delete करते हैं. ठीक है. अगर ये डिलीट नहीं होता है तब आपको कोई प्रॉब्लम नहीं है. देन इन दैट केस व्हाट वी डू इज वी सिंपली कंट्रोल सी एंड ऐड इट ओवर हियर, बिकॉज इसमें डेटा ऑलरेडी था इसलिए वो डिलीट नहीं करता है. ठीक है. सो यहाँ पे हम क्या करेंगे, व्हाट वी आर गोइंग टू डू इज वी आर जस्ट गोइंग टू प्रेस कंट्रोल जी, स्पेशल, blanks, all the empty spaces are selected, blank, then you just press print equal to the previous value and then you press Control Enter. Is this okay? Is this okay now?
Yes, ma'am.
All right. So I'm just going to show you a little code that I have already done because I knew that there will not be much time. So it's a very, very simple code, financial data code. Not many libraries we have to use. Only we are using NumPy, Pandas, and this is for Arima. And this is for plotting. So you just need to upload the data over here. You all of you know. Here you need to upload the data, right? So whatever the data is there, you just need to upload it. And using this function, read_CSV, we are just going to read the data. So if you look at the head, we have just only two things. One was the date and second was the index value. And this is the value. And obviously here also in Python, what we are going to do is we have to convert, we have to make sure that this date is in the date format only, right? Otherwise, agar iska format jo hai, it is something else, it is object or it is text, then your Arima model or Arima model we cannot apply. So what we are going to do is we are just converting into date time format so that we can apply our forecasting models. Right. So this particular statements, what we have done is we have just converted it into date type. So we are trying that, okay, the data is in place is equal to true means जो data है उसी में ही हम change कर रहे हैं. We are not creating any new data frame here. So if we plot the data, I'm just going to ask you a single question here. What you can see is about the data, whether there is a trend that you can see in this data. Is there any trend or any seasonality that you can see in the data by looking at the graph? Anyone? I just know the name of Rajneesh sir. It's a very simple question. Can you see any trend in this data?
Ma'am, as the time is increasing,
Yeah,
so
there is a kind of upward trend. The data is having increased values. With the date, the data is showing an increasing trend. Okay.
yes.
And can you see any seasonality in the data? कि किसी सीजन में ये पीक ले रहा हो, किसी सीजन में नहीं ले रहा हो और ऐसे चेंज हो रहा हो, वही ट्रेंड चल रहा हो?
Yes, after 1 or 3 slab, it will be in a peak.
Correct.
एब्सोल्युटली आप देख सकते हैं पहले ये लो है, फिर उसके बाद एकदम से कोई सीजन आता है जिसमें ये पीक लेता है, फिर उसके बाद फिर से लो होता है, फिर सीजन पे ये पीक लेता है, फिर सीजन पे ये पीक लेता है. तो वी कैन डेफिनेटली सी दैट ओके देयर इज सीजनैलिटी as well as up increasing upward trend also, right? So I have told you that okay, by looking at this data, if I ask you ki, sir, whether this data is stationary or not, you will not be able to answer me, ma'am. I cannot tell you the answer because I really do not know the whether the mean is constant over time or variance is constant over time, right? So the one thing that we can do is we can just compare the 12 months simply moving average along the time series to check. Now, what I have done is we have just plotted the standard deviation. So can you see that whether it is constant or whether it is increasing? The variance. Yellow line or orange line is actually representing the variance. Whether variance is showing certain trend or not. Yes, sir. वेरिएंस आपको ट्रेंड दिख रहा है, कोई बढ़ रहा हो, कम हो रहा हो, या फिर कांस्टेंट है?
Slightly increasing.
Not slightly increasing, it is almost constant, this line.
Okay.
Right? And if you look at the mean also, it is almost constant. It is slightly increasing. So we can definitely say that, okay, this is stationary data, but again, we are not very sure, है ना? जैसे अब देखिए आपका और मेरा ही व्यू पॉइंट अलग हो गया. आपने कहा मैम थोड़ा इंक्रीज हो रहा है, लेकिन मुझे लगा कि ये कांस्टेंट है. So it is better that we should be applying statistical test, right? Okay. The tool that I have told you is Decay-Fuller test, है ना? Decay-Fuller test जब हम अप्लाई करते हैं, उससे पहले what we have done is वैसे तो ये हम बाद में भी कर सकते थे उसके components में, पहले हम यही देख लेते हैं. हम Decay-Fuller test अप्लाई करके देखते हैं कि उसकी वैल्यू क्या आती है. अगर वैल्यू जो है वो लेसर देन 0.05 है, ठीक है? If it is less than 0.05, then we are going to reject our null hypothesis. Our null hypothesis says that the data is stationary. And if it is greater than 0.05, then we are going to say that the data is not stationary. So the value that we have calculated is 0.1. ठीक है? So 0.1 का क्या मतलब है? That it is greater than 0.05. That means my data is not stationary. वो चीज आपको कहाँ से दिख रही है? आपको यहाँ से दिख रही है ना कि ये डेटा स्टेशनरी नहीं है. वेरिएंस तो इसकी फिर भी कांस्टेंट है, लेकिन अगर आप मीन को देखें तो मीन तो इसका बढ़ रहा है विद रिस्पेक्ट टू टाइम. अगर मीन भी इसका इस तरह से आता, then we could have said that okay, the data is stationary. So this is why we apply these statistical tests. So this is your Decay-Fuller tests result. So what we are going to do over here is, now what we are going to do is we are going to do the differencing, so that my data becomes stationary. So what we have done is we have done the differencing of the data. I have taken the difference of this value with the previous value. So after taking the differencing, this is what I'm doing is I'm actually making my data stationary. Now here you can see that if I'm going to find out the mean, it is almost going to be the constant. And if I'm going to find the variance, that is also going to be the constant. But again, we are not sure. We are going to find out the Decay-Fuller test again. Yes. Okay, the value which came out now is 8.8, which is quite higher than 0.05. Now we can simply say that the data is stationary. Now, if we have to see what are the various components in my data, this is the function that I apply, that is decompose. Right? So I have decomposed the time series into 4 components, 4 vital components. First was the values, the trend, which you can see, seasonality, and the random error. Now, okay, next if we find out the autocorrelation and PACF plots. Okay. Before I move ahead, I just need to clarify one thing here. What exactly is autocorrelation and partial correlation represent? Because I have not calculated this thing, so that is why there was the error. This one. this one. Okay. So now what I'm trying to tell you over here is that what this ACF and this is 4 value. This is again greater than 0.05. So you can easily drop your differencing now.
ಏಳು ಕುಂಡಲವಾಡ ಗೋವಿಂದ ಗೋವಿಂದನ.
Kindly mute yourself. I'm just going to take a little more time. That's it. You are not supposed to interrupt and then ask me to stop. I'll be stopping in a while. Okay. Just one important thing that I need to tell you over here is what this ACF actually plot is. है ना? देखिए ये ACF जो है, it represents a correlation coefficient and these are the lag values. What do I mean by the lag values? Means time interval. किस time interval पे था? ये represent कर रही है कि the what is the correlation between this value and the same value? ठीक है, तो same value में तो obviously correlation 1 ही होगा. Now ये क्या represent कर रही है that what is the correlation between this value and previous one value? प्रीवियस वाली कौन सी वैल्यू के साथ इसका कितना कोरिलेशन है? तो पास्ट वन वैल्यू के साथ इसका इतना कोरिलेशन है अराउंड 0.35. ये क्या रिप्रेजेंट कर रही है कि करंट वैल्यू और प्रीवियस लास्ट से लास्ट वाली वैल्यू पे, ठीक है, अगर दिस इज x तो x माइनस 2 के साथ इसका कितना कोरिलेशन है, और ये क्या रिप्रेजेंट कर रही है x 3 पे कितना कोरिलेशन है. मतलब हम ये देखना चाह रहे हैं कि जो करंट वैल्यू है वो कौन सी वाली लास्ट वैल्यू पे सबसे ज्यादा डिपेंडेंट है, सबसे ज्यादा उसका कोरिलेशन कौन सी वैल्यू पे एग्जिस्ट कर रहा है, प्रीवियस वैल्यू पे एग्जिस्ट कर रहे हैं या उससे प्रीवियस या उससे प्रीवियस या उससे प्रीवियस. तो हम बड़े आसानी से देख सकते हैं कि 2 वैल्यू छोड़ने के बाद जो तीसरी वैल्यू है उस पे जाके इसका जो है मेन कोरिलेशन आ रहा है. तो मतलब क्या है, यहाँ पे आप इसको क्या बोलोगे कि हमें पास्ट 3 वैल्यूज तो कंसिडर कर ही लेनी चाहिए, है ना, बिकॉज जो हाईएस्ट कोरिलेशन है वो t-1 पे नहीं है, वो t-2 पे नहीं है, वो t-3 पे है. यस
Ma'am, please in English, ma'am, please.
Yeah, I'm so sorry. I'm so sorry about it. I'll go to. Yeah. Please, I'm sorry about this. So what exactly this correlation graph represent is this this axis, this represents your correlation coefficient, and this axis, it represents your lag value, right? What do I mean by lag value? The interval value. So the first point, it represents the correlation of the value at xt with the value xt. So obviously the correlation of a value at xt with the xt, the correlation of a value with itself, that will obviously be 1. So the second point, it represents the correlation of the value at xt with xt minus 1, that how much these two values are related. This represents the correlation of xt with xt minus 2. This represents the correlation of xt with xt minus 3. Again, if you see, the trend repeats itself. Now here, if you look at this graph, you can easily say कि ma'am, instead of taking the past value, past single value or past single and one or more value, we should take past 3 values, because we can easily see that the correlation is highest between this value and this value. So this is how we actually define the term AR. Okay, so how many previous values? So if you look at the equation, how many previous values I have to consider to forecast my current value, correct? Is it okay?
Yes, ma'am.
Fine. So the second thing is partial autocorrelation. So there is a slight difference between ACF and PACF. Kindly hear patiently, you will be able to understand. So what it represents? It represents the correlation of current value with the previous values, considering all the values in between. What do I mean to say? The first value is obviously the correlation of xt with xt. this obviously will be 1. You have to neglect this value because obviously the correlation of this value with itself is going to be 1. So this represents the correlation of xt with xt minus 1. But this value, this represents the correlation of all the values between xt and xt minus 2. Means it is going to consider the impact of xt minus 1 as well. This value is the correlation of xt and all the values between xt and xt minus 3. Means this value is going to consider the impact of xt minus 1, xt minus 2 and xt minus 3. Right? Means previous how many values are having impact. So this is going to give you your moving average. So this was all. What we had done is we have actually converted our non-stationary data into stationary data. Now we can easily apply our Arima model. Arima is same as your Arima only. Okay, what we need to understand is we just have to find out the order of P and Q only. So this is the summary. So these are the residuals. What are the errors in each value that we have found out? Okay, so if you look at the error plot, right, what it shows over here is that most of the errors are closer to 0 only. I have just plotted this residual plot for you so that while visualizing, you'll be able to understand that most of the residuals are near 0 only. So that means our results are quite good. So if you talk about, this is the prediction. So I have predicted the already existing data. So if the data is already, we have just predicted on the training data only. So training data, obviously what you're going to get is 100% accuracy. So that is why you're not able to even see the blue line also. But if you have to predict for the future, so what is there? This is how we are going to predict. We have given the starting point and the ending point. Till now, this was your original data and this is your future data. So you can look over here. It gives you quite good feeling that the data is giving you good forecast. But in that case, what you have to do is again, you have to apply the forecast errors, which is actually going to give you the main performance evaluation matrix. So what exactly is the performance metric value, that is RMSE or MSE or MAE values? So that is it. That's all from my side. I am open to questions. If you need to ask any question, you can ask. Is there anything that you want to ask?
From these existing algorithm, do we have another application for the forecasting?
We have numerous number of applications, not only for financial data, for medical data also. You must have seen in the news that IIT Delhi have predicted the COVID cases so well, right? For inventory management, for this disease forecasting, that okay, number of cases this year, next year, sales forecasting, everywhere we have got the application of prediction and forecasting. Since the topic was financial data, so that is why I've taken the example of financial data. The applications are numerous.
Okay, ma'am. And the authenticity of that forecasting data, how much percentage we can like estimate?
It all depends on the source of your data, right? So if you're taking this data from an authentic source, then definitely your data would be giving you correct result. For example, I've taken the data from the official website. So we know that, okay, this is official website. If I would have taken the data from any XYZ, then my results will also not be so authentic in that case.
Okay, okay. Thank you, ma'am.
Thank you, Rohit.
Possible to apply this for images?
No, no.
But we can
In that
extract
case,
the
you'll be
features.
using your classifiers only.
Okay. If it is possible to extract the features using some algorithm, then the Excel sheet can be applied to this, no?
Yeah, if you are able to extract the features out of your images along with the time, then you will be able to apply this. But directly on images, you will not be able to apply this.
Can't able to. Thank you very much.
Okay, thank you, Hema.
So probably you can apply on the videos. Means you have the specific.
Yes, you'll be having, images at times. Yes, Dr. Ravi.
Okay, ma'am. Okay, sir. Thank you, sir.
Okay, so thank you, participants. We'll meet tomorrow. Okay.
Thank you, sir.
Thank you, sir.
I'll be sharing the attendance and the feedback form in the WhatsApp group itself. Okay.
Hello, Raj Chaudhary sir.
Yeah.
If possible, sir, this session record link, sir, please you share. This is very
Yeah.
fantastic session.
Definitely. We will
Yes,
form.
sir. Please share the recorded session.
This is
File
very
for
nice and very informative, sir. Please share it, sir.
Sure. We will.
Sir, can it be done on day-to-day basis? Means when we have done with 3 sessions today, can this recorded version be mailed us by today or by tomorrow morning, or will it be after the complete FDP ends?
Ma'am, we will check on that. We will try to do it on day-to-day basis itself if possible.
That will be more beneficial, I guess.
We might need to do some editing over the video.
Okay, sir.
Maybe, but we will then, because we need to crop and all those things for the size and everything. And
Okay.
that we will do it. Okay. But
Thank
we
you,
will
sir.
try to do it on the day-to-day basis.
Okay, thank you, sir.
Thank you, sir.
So can we leave the meeting now?
Yes, we can leave. I'm sharing the link.
Attendance and on the WhatsApp group. Okay, sir.
Yeah.
Okay, sir. Thank you, sir.
Yeah, thank you so much.
I'm sorry, I got disconnected. Is there any other question? I was just about to conclude only. I guess as soon as I left, there are so many candidates who also left.
Yes, ma'am. Actually, we thought of that you might got disconnected, so we have ended this session. But ma'am, they are very happy to attend your session, and they were really.
Thank you so much, Shambhu, for such good feedback. This actually inspires us also to work hard. Thank you so much.
Ma'am, thank you very much. Your session is very fantastic. And
Thank you, Leela, and I'm very sorry about the usage of Hindi.
no,
I
ma'am,
just
I
forgot.
can understand little bit. Fully, I
Okay.
got able to understand. That's why I interrupt your session.
Okay,
Otherwise,
thank you.
your
Thank you
session
so
is
much.
fantastic, ma'am.
Thank you.
Thanks for you.
Thank you.
Thank you.
Thank you.
Thank you, ma'am. It was a nice session.
Thank you, KK sir. Thank you. So I hope to meet you all in near future, and all the very best to everyone. Thank you for listening to me so patiently and for your nice words.
Thank you, ma'am. Thank you.
Thank you.
you.
So much.